Problem 3. Find the area of the region enclosed by the graphs of x equals 12y squared minus 12y cubed and x equals 2y squared minus 2y. Please notice that my equations are in terms of y, so I will be using y values. And instead of doing top minus bottom, I will do right minus left. And they nicely gave me a picture, which is nice. So if I'm setting up the area, and it already is graphed for me, so I don't need to do that. I can just go ahead and jump right into getting the area. I'm going y values, and it's easy to see from this picture that it's going from a y value of 0 to a y value of 1. So we're going to go from 0 to 1. And then when I do the right curve is the 12y squared minus 12y cubed. And then minus the left area would be 2y squared minus 2y dy. And then from there, that is the setup. So I'm pretty much set to go. I can, at this point in time, use Math 9 on my calculator. And when I do that, I will get 1.333. And please notice I am accurate to 3 decimal places. All right, problem number 4. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x plus 2, y equals 0, x equals 0, and x equals 2 about the line x equals 4. So let's go ahead and draw the graph. Y equals x plus 2 is a line going through the y-axis at 2. And then we've got y equals 0, which is down here. We've got x equals 0, and then x equals 2. So the region in question is going to be this region right here. We're going to revolve it about the line x equals 4. So we're going to revolve it over here. It's going to end up looking something like this over here, and though it doesn't really matter what it's going to look like. It is a vertical axis of revolution, so I'm definitely going to use the shell method. So when I'm setting up my shells, I'm going to have 2 pi. The region goes from 0 to 2. Those are x values. And then since we're about the line x equals 4, instead of the x-axis, our p of x is going to be 4 minus x. And our h of x, just like always, is going to be top minus bottom. And I think I'll just write this formula here just to make sure we know that. It's always p of x and h of x, which is top minus bottom. Okay, so if I look at the top is the curve x plus 2, and the bottom is just 0. Okay, and if you wanted to clean that up a little bit, you could. After I go ahead and type that in my calculator, we again get to use the Math 9 feature. Since we're on the calculator section, we should end up with an answer of 108.909. All right, question 5. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals 4 minus x squared and y equals 0 about the line y equals 4. Alrighty, so we are going to go ahead and draw the graph of 4 minus x squared, which is a upside down parabola. There we go. It's going to look like that, and y equals 0. So my region in question is right there. I'm going to revolve it about the line y equals 4, which is up here. So it's going to revolve about this line, which means it actually is going to be going up here, and that's where it's going to kind of be repeating. Okay, biggest thing, it's a horizontal axis, so I need to use either the disk or the washer. And I notice that not all of the pieces of the graph are touching each other when I revolve it, so this is definitely going to be a washer problem. Okay, so washer, we're going to have volume equals pi. It's going to go from an x value to an x value. And if you look at where those two intersect the x-axis, that will be at -2 and +2. And then from here, I have 2 shapes in question, and I'm going to just draw a vertical line going through those. And so if I'm looking at these dots, which dot is furthest away from the axis of revolution? It's the dot that forms from y equals 0, so I'm going to put 0. But then, since the line is up at y equals 4, we have to subtract 4 from the equations that we're working with. So we're going to put 0 minus 4 squared, and then minus the inner radius. If I look at this dot is closer to that axis, so it's the curve 4 minus x squared, and again I need to move it down 4, and that will be squared, because remember for washer it's outer radius squared minus inner radius squared. And then from here, again, I'm going to use the Math 9 feature. I'm going to let the calculator do all of the work for me, and when I do that I should get 160.850. Okay, problem 6. The base of a solid is bound by y equals x squared, y equals 0, and x equals 3. Find the volume of the solid for semicircular cross sections taken perpendicular to the y-axis. So first of all, again, let's get our picture drawn. We've got y equals x squared. We've got y equals 0 and x equals 3. So this is the region in question. And this time we're going to take cross sections perpendicular to the y-axis. So if the y-axis is going this way, my cross sections are going this way. And since I'm perpendicular to the y-axis, my equations should have y's in them. And then the other thing, we are going to go right minus left for this one when we're coming up with anything. So I'm going to have volume equals. This is going to go from, remember, if I'm doing anything with y's, it's going to go from a y value to a y value. So I can definitely tell it's going to go to 0. But to get the problem up here, it's actually where y equals x squared and x equals 3 are intersecting. So I noticed that it's when x equals 3, so we can plug 3 in for the x, and 3 squared is 9. So it's going to go 0 to 9. And then when I do, well, actually I'll just put area of x, area of y this time, dy. I'm going to go off and do a little side trip. Since I have semicircles, I know it's going to be 1/2 pi r squared. So it's going to be 1/2 pi. The radius is going to be right minus left. So if I'm looking at the line that I drew, the right side is the line 3, and then minus the left side is the, where do I write it? Y equals x squared, but this equation should have y's in it. So I'm going to solve it for x. So to get rid of the x squared, I'll square root both sides, and I'll get x equals plus or minus the square root of y. But I do notice that it's only touching it's ending at the positive square root y. So I'm just going to put the square root of y. And then the other thing, please remember when we're doing this, if I were to draw that semicircle, that would form the diameter of the semicircle, and I only want the radius, so I actually have to divide that by 2, and then the whole thing is squared because it was radius squared. Okay, so now I'm just going to plug that back into my formula. My area I found out was 1/2 pi, and then 3 minus square root y over 2 squared dy. And then from here again, since it's on the calculator section, we'll hit math 9 for this one, and we should get an answer of 5.301.